Okay. Alright, so my presentation for the teaching category is on the agencies of aspartame. And by the end of this presentation, we'll have a class discussion on whether or not aspartame should be taken off of the market. So, in the first place, what is aspartame? And you get a starters. Yes.
It's a fake sugar product.
Good job, Derek.
Fake Coke.
Good job. Anybody else? What's aspartame?
Sweetener.
Sweetener. Good job. Aspartame is an artificial sweetener. If you've heard of the products Canderol, NutraSweet, or Equal, those are all actually aspartame. The scientific compound of aspartame is C14H18N2O5. As you can see, that relates to the molecule right there. The O5s are in red, and the compound for oxygen is in red. And there are three components of aspartame when it's digested in the body that it breaks into. And those are aspartic acid, phenylalanine, and methanol. And we will get to each of those three a little bit later on. So, how is aspartame discovered?
James Slaughter.
Good job, James Slaughter. In 1965, discovered aspartame at GD Cereal and Company, and keep that name in mind because the company's name in mind because that's important a little bit later on. Company's name, GD Cereal and Company. Yeah, and that company currently makes imaging equipment and prescription drugs. So, James Slaughter was actually attempting to make an anti-ulcer drug when he accidentally licked his fingers when he was turning the page of a book and discovered the sweet taste of the drug. GD Cereal and Company did some research on it, and that anti-ulcer drug eventually became aspartame. And GD Cereal and Company currently makes the sweetener NutraSweet, which I'm sure you all have heard of. And in 1992, the patent for aspartame actually expired, so a bunch of other companies are now able to produce products that contain aspartame, which is why there's products like Canderol and Equal. So, some key terms, and this ties into your Aspartame 101 worksheet, so you can pull that out.
1 second. Got it.
Got it? Okay. So we need to go over these before we start talking about the science behind aspartame. The first one is sucrose. Sucrose is just common table sugar, and it is the most common sweetener in the American diet, and aspartame was created as a substitute to sucrose. Then amino acids. They are critical in the human body and play a role in our metabolism. Amino acids are the building blocks of proteins, and they can be categorized as either an essential amino acid or non-essential amino acid, and that's also on your worksheet. That's important to remember because we're going to be dealing with both essential and non-essential amino acids in a little bit. And an essential amino acid is one that cannot be produced by the body, so it can only be found from outside sources, so from your diet. And then the 11 non-essential amino acids are ones that can be produced by the body. Then proteins, they are large molecules comprised of amino acids, and they carry out many of the functions in the body. For example, they help regulate the growth and repair of body tissue. And then, finally, the FDA. The FDA, also known as the Food and Drug Administration, is responsible for regulating and determining the safety of $1 trillion worth of food, prescription drugs, dietary supplements, and cosmetics. And aspartame had to go through the FDA to be able to be approved to be on the market today. Did everybody get that?
Yeah.
Yeah? Okay. Alright, so the science behind aspartame. There are several names for aspartame. You could call it any of these. And the one that we'll be working with is the L-aspartyl-L-phenylalanine methyl ester. And you can see that on the bottom of your sheet in the little picture. It's the same name. And the reason that we're working with that name is because it talks about the three components of aspartame: L-aspartyl, aspartic acid, L-phenylalanine, phenylalanine, and then methyl ester, methanol. So the first one is aspartic acid, and then phenylalanine and methanol. So aspartic acid is a non-essential amino acid, which means that it can be produced by the body, and is found in dairy, beef, and sprouting seeds, so not just produced by the body, but can find it in outside sources. It is needed for stamina, brain, and neural health, and is important for maintaining proper pH level in your blood. It removes excess ammonia and toxins from the blood as well, and plays a role in manufacturing glucose. And aspartic acid is essential for our metabolism. So phenylalanine is the second component that aspartame breaks into. It is an essential amino acid, which means that it cannot be produced by the body. It can only be found from an outside diet. Phenylalanine comes in 3 chemical forms. So if you notice the L that you see on your worksheet, that's the one that we'll be working with. It's the natural form of phenylalanine. There's also D-phenylalanine, which is the synthesized version, so it's the mirror image of L-phenylalanine. And then DL-phenylalanine, which is a combination of the two. But again, we're working with L-phenylalanine. And it is found in beef, fish, dairy, and soy products because it can only be found from outside sources. And a major portion of what we'll be learning about today is when somebody is not phenylalanine deficient, but if they suffer from the metabolic disease phenylketonuria, or PKU as it's abbreviated. But if you're merely phenylalanine deficient, you would have symptoms that include confusion, lack of energy, depression, or a decreased appetite. And we'll get to phenylketonuria in a little bit. And then finally, methanol is the third component. Methanol is a colorless, flammable, toxic liquid. Can be used for a variety of reasons. The number one use is to make other chemicals. It's also used in explosives or a solvent in a lab. And it is a neurotoxin. It is highly toxic. In fact, in the material safety guide that can be found online under the potential health risks, they say that ingestion may cause serious poisoning with effects similar to those of inhalation and absorption through the skin. Toxic effects are common after ingestion. Death after as little as 1 ounce has been reported, so it's highly toxic. And there's an initial wave of symptoms that you get from methanol if you ingest it, and they include dizziness, nausea, confusion, drowsiness, and after that first wave, there's a second wave that involves blindness or blurred vision for a certain period of time. And an important thing to notice is that your sheet actually says methyl ester, and the ester derivatives of methanol are not toxic. So what's actually going into your body is not toxic, but the bad thing is that once aspartame is metabolized, it breaks down into 3 components: aspartic acid, phenylalanine, and methanol. So it actually breaks into the toxic chemical. Okay, so aspartame and the FDA. In 1965, aspartame was discovered by James Schlatter at G.D. Searle and Company. In 1981, it was approved initially only as a tabletop sweetener. By 1983, it was approved for use in diet beverages and a few other products. But by 1996, it was approved universally across the board in any product. And yeah, it's in all of those products. And there's been a lot of controversy surrounding aspartame and its approval in the FDA. We'll get to that right now. So first of all, the process. You have to learn about this before we talk about the controversy. Aspartame falls under the Dietary Supplement Health and Education Act, which was created in 1994. And basically, the FDA mandates that aspartame is regulated as a food rather than as a drug, which means it doesn't have to go through any safety testing, doesn't have to meet any requirements, and it can only be taken off the market after it's been proven to have problems, so it just can go onto the market. But again, this was put in 1994, so aspartame has been on the market for quite some time and had been through all this testing before this happened. And because of this, companies that use aspartame are required to have function claims on labels, and you'll see some of those later. They're on the nutrition labels, and yeah, we'll be looking at that. So the controversy doesn't actually revolve around how aspartame was studied or researched, but it revolves around how it was passed by the FDA. It's widely acknowledged that aspartame is one of the most heavily researched ingredients on the market today. There's somewhere between 100 and 200 studies that have been done on it since its approval in 1981. And it's been studied on several subpopulations, for example, people who have diabetes, pregnant women, or people who suffer from phenylketonuria. But like I said, it doesn't revolve around how it was researched. It revolves around Dr. Arthur Hall Hayes, Jr., who was the president of the FDA at the time of aspartame's approval. He became president